Hi everyone, in this video I'm continuing to work through question 11 part C of the 2020 Extension 1 trial exam from James Ruse. So I'm up to the very final part of this question, which is part 3 subpart beta. So if you haven't already, take a look at my videos for part 1, 2 and 3 part alpha, since this part beta really follows on from all of that work. So here for part 3 beta, we're being asked to solve the equation f theta equals 0, where we were told at the beginning of part 3 that f theta is equal to 1 minus 3 cos 2 theta minus 4 sine 2 theta, and theta having the domain between 0 and pi. So yeah, let's take a look. So here we're being asked to solve f theta equals 0, and I think a natural first step is to put in our I guess, simplified version of f theta that we got to in part alpha when we made use of the result in part 1. So if we want f theta equal to 0, that's essentially the same as saying that 1 minus 5 cos 2 theta minus alpha is equal to 0. And if I bring this minus 5 cos 2 theta minus alpha over, we essentially end up with, I'll bring it over and then swap them around. So we'll end up with a positive 5 cos 2 theta minus alpha being equal to 1. Or in other words, cos 2 theta minus alpha would be equal to 1 on 5. And noting that it's essentially the cosine of an angle, and it's positive. So we know that this is going to have two solutions when we're in the domain of this angle being between 0 and 2 pi. So essentially we can say, since this is positive, we can say cos of 2 theta minus alpha will being equal to 1 on 5 has two solutions for the domain, the 2 theta being between 0 and 2 pi. So if I just divide everything by 2, that's essentially the same as saying 0 being between, or theta being between 0 and pi, which I think is important to note since that is the domain that we're being told to use for this question. So I think it works. I think whilst we're dealing with 2 theta, between 0 and 2 pi, using that technique, we're still going to end up with the correct domain. So in terms of how do you work out those two solutions, the way I was taught is a kind of acronym that maybe only works if you live in Sydney. But if you've got your quadrants, we would use at all stations to central, which is basically a reference to the train network in Sydney, where often many trains, once they get to a certain point, they'll have all stations to central station. And so we know that depending on the trig function, you're going to have all of them have a positive value in this first quadrant, and then the other quadrant that gets the positive value, whether it's sine, tan or cos, you can use this acronym to help you. So we know that we're going to get a positive value, in our case 1 on 5, when we're in the first and last quadrant. So if I kind of just sketch a rough sketch of what that would look like, if I draw this triangle here, this right triangle, and this is our angle, which for us is 2 theta minus alpha, we know using SOHCAHTOA that cos is adjacent on hypotenuse, so adjacent on hypotenuse for us would be 1 over 5. And again, this is a positive 1 because we're moving in the positive direction, and a magnitude of 5. So the idea is that, again, in this last quadrant, you could draw effectively the same triangle but just a mirror image. And we've got our adjacent here as 1, if we're thinking now of this angle, which it's the same magnitude of angle, just kind of coming in the opposite direction. So 2 theta minus alpha. And again, this would also be 5. And the idea that you get 1 over this magnitude of 5 also being a positive result. So the idea is we're going to have two solutions. The first solution is you just kind of work it out as you normally would. You kind of take the inverse cos and then rearrange for theta. And then the second solution, we can think of, it's essentially, if we start from here when we're measuring our angles, the first solution goes from here to here, as usual. The second solution you could think of as going all the way around. So we're going all the way around, say 2 pi, and then coming back this angle, this 2 theta minus alpha. So it's essentially 2 pi going all the way around, 2 pi or 360 degrees, minus whatever the solution is that we work out as being the first solution. So that's the way you can think about it. I might have to turn over to do this work, but let's start with our first solution. So our first solution we can get to by just saying that, well, if I start with cos 2 theta minus alpha equals 1 on 5, so we've got cos 2 theta minus alpha equals 1 on 5. So I want to isolate the theta, so I'll take the inverse cos of both sides. So we'll have 2 theta minus alpha is the inverse cos of 1 on 5. Then we bring our alpha over, so we get 2 theta is alpha plus the inverse cos of 1 on 5. And then we want to divide that by 2. So we end up with theta being equal to 1/2 times alpha plus the inverse cos of 1 on 5. And at this point, it probably makes sense to plug all this into the calculator. So you may remember all the way back in part 1, I stored the result for alpha in decimal form. So might as well first calculate this inverse cos of 1 on 5 and get it into decimal form. So we'll go inverse cos of 1 on 5, and that's in degrees. So if I divide by 180 and then multiply by pi, that gets it in decimal form. So that's that bit there. So now I'm going to add alpha, so plus what I stored as alpha. And then I want to divide that by 2 because we're taking 1/2 of that. So for that, I get 1.148. Say, let's just go to 3 decimal places. It keeps going, but that's probably enough precision. So that is the solution. That is the value of theta that solves f theta equals 0. So that's the first solution. So now, as I mentioned, that we know there's going to be 2 solutions, and we use this all stations to central. So now for the second solution, we can say that our 2 theta minus alpha, the angle 2 theta minus alpha, is going to be essentially 2 pi minus our first solution. And remembering the first solution for 2 theta minus alpha was the inverse cos of 1 on 5. So it's going to be 2 pi minus the inverse cos of 1 on 5 is how we can then work out the second solution for 2 theta minus alpha. I think you need to be super careful there, because I could imagine many students make the mistake of taking this as the first solution and doing 2 pi minus this, but that's not actually what's going on. We're actually using our all stations to central to get the angle, the total angle, which for us is 2 theta minus alpha. So the first solution of 2 theta minus alpha was actually just inverse cos of 1 on 5. So it's 2 pi minus that gets us our second solution, and then we rearrange just for theta, since theta is what we're concerned with. So we got 2 pi minus inverse cos of 1 on 5. So I'll bring the alpha over, so we get 2 theta equals alpha plus 2 pi minus the inverse cos of 1 on 5. And then again, we divide by 2 to get theta by itself. So we get 1/2 times alpha plus 2 pi minus the inverse cos of 1 on 5. And now we want to plug all this into our calculator. So again, I might just start here. So we'll go, the inverse cos of 1 over 5 is that. And then we divide by 180 and we multiply by pi. And we actually want 2 times pi minus that answer. And now we want to add our alpha, which I've stored from part A. And then we want to divide that by 2 since we're taking half. So there we get 2.921 if I'm rounding to 3 decimal places. And then there's obviously more decimal places, but that's just the precision I've generally been using. If you kind of look back at the rest of the parts of this question, I've typically just used to 3 decimal places. The question didn't actually say, but I think 3 decimal places is probably a good level of precision if you haven't been specifically told what to do. So yeah, and that's actually it for that question. We've got our 2 solutions for theta specifically, because we're wanting to solve when f of theta is equal to 0. But I think the trick to this question is to essentially do the work over this total angle, 2 theta minus alpha, noting that you end up in the same domain anyway in terms of thinking about 2 theta. You end up with theta itself being between 0 and pi. So kind of making use of this all stations to central, something you may have learned actually quite a few years before you're doing your HSC, but it's just one of those many things in the spiral curriculum with math. You're often revisiting topics and just going deeper into them. So you might have learned this for the first time quite a few years ago, but you have to stay fresh on all of it because you never know when you're going to have to make use of it again. So hopefully that's all made sense. You followed along with all that. And yeah, that's the end of this question 11 part C. So hopefully that's all been helpful. And tick boom.